All right, so this part of the experiment, the goal is to measure the magnetic field starting from little bit past the first coil and all the way to past the furthest coil. So in order to do that, we need the magnetic field sensor and the position sensor. So here, as I mentioned earlier, so the center point over here going to be the 0 position. So in our experiment, we need to set this position as 0. So what I'm going to do is I'm going to move the magnetic field sensor to this corner, and then I set 0 in the position on the capstone file. So I'm setting up my data collection to read this position as 0 position. Then, as you all know, everywhere around us, the Earth magnetic field is acting, right? So we do have an Earth magnetic field around this experimental setup as well. So we cannot ignore the magnetic field, right? But simply we can remove the Earth magnetic field from our data. So in order to do that, we can use the tear button in the magnetic field sensor. So what we're going to do is we're going to move this magnetic field sensor all the way to somewhere here, further away from the coils, and set the tear button. So we can remove the Earth magnetic field from our data. So again, we are not going to ignore the Earth magnetic field, but we're going to keep it aside from our data. All right, so now we are ready to collect the data. So what I'm going to do is I'm going to move this magnetic field sensor across the coils and record the magnetic field with respect to the position of the sensor. Now, when you do that, the data will look like as in this graph. So my graph is the graph between magnetic field and the position. So the graph of magnetic field versus the position is shown here, and I'm going to share this data with you. And the current that I use in the circuit is 0.426 amps. Now here, as you see, the y-axis read the magnetic field in Tesla, and the x-axis read the position in meters. Now, the blue curve here represents the theoretical magnetic field variation with respect to the position, and the red color data represent the experimental value, right? So the experimental value represented by the blue color diagram here. So on the equation 2, you have to compare the two curves. So what is your comments about these two graphs? Then if these two lines, like if it is a theoretical value and the experimental value, they should be overlapping to each other, but here it is not, so a little apart from each other. So can you comment on that? So that's resulting from the experimental errors, right? So can you think about a couple of experimental errors that you might have made when collecting data? I know you didn't collect the data, I did, but it's coming from the theoretical calculation and the measurements, right? So you can think about like what are the factors that we measured in order to get these data. So in that point, you might be making some mistakes or the errors in the measurements, right? So you may think about that. Then in question 4, it's asking how many times more powerful is the field of your setup at the midpoint compared to the Earth magnetic field. So Earth magnetic field is about 1 Gauss, which is 1 times 10 to the power minus 4 Tesla. Now here, in order to compare those two numbers, you need to know like what are the values over here. So this is my experimental graph. So over here, if you are in the lab and using the capstone to measure it, then you will be using this coordinate tool and read this value. So here I'm going to read that value for you. It's going to be 0.00191 Tesla. Now, in order to compare this number with the 1 Gauss, you need to write it in scientific form method. I mean the scientific notation into the 10 to the power minus 4 values, right? So if you write it like here, if I convert this one to scientific notation, it will be a 19.1 10 to the power minus 4. So my experimental magnetic field value is 19.1 times 10 to the power minus 4 Tesla, right? So please compare these numbers and think about whether we ignore the magnetic field that's coming from the earth or we just leave it from our data. All right, so if you have any questions, you may talk to us through Zoom or you may email us. Then the one last thing. So here I didn't attach the fillable PDF. So one thing that you could do is you may write your answers on a paper and scan it and save it as a PDF or a picture and submit that. Or you may type your answers on a Word file, save it as a PDF and submit. Right? So you may choose either, because last time we had some issues about the fillable PDF. So we are not going to use that fillable PDFs in this lab. Thank you, and please spend your time properly to complete this lab.